This video is designed to help you make a confidence interval for a population proportion. The goal here would be to provide a range of values within which you expect P, which is just some unknown population proportion, to fall. There is a formula for this, and this formula is in your formula sheet. That'd be this: P hat, which is a sample proportion plus or minus Z star, which is a critical value. And that guy you can find in the formula sheet using this table, times this square root term, and this is the standard error, the square root term. P hat is a sample proportion, Q hat 1 minus P hat, N sample size. These should all be given in the problem, and again Z star you would use that table to figure out. An example problem: a grocery store is considering adding a delivery service and wants to know what proportion of their customers would pay a reasonable fee to have their groceries delivered. They randomly select 84 customers and find that 39 of them would pay the fee. With this data, create a 95% confidence interval for P, and here P would represent the proportion of all customers that would pay for this delivery service. So here we would have that P hat is 39 out of 84. Which is 0.4643, and then Q hat would be 0.5357. There's just 1 minus P hat. N would be 84, and Z star, if you use the formula sheet, 95% confidence would be 1.96. Now it's just a matter of plugging things into this formula. And we have P hat, we have Z star, we have Q hat, and we have N. So I think if you plug things in, you end up with 0.4643 plus or minus 0.1067. This guy would be the margin of error, and this would give you an interval of 0.3576 to 0.571. I would use the minus sign to get the lower boundary, use that plus sign to get the upper boundary, and if you wanted to interpret this interval, your interpretation would look something like this. We can be 95% confident that the true proportion of all customers who are willing to pay the fee is between 0.3576 and 0.5710.